tutorial explains the transient heat transfer analysis of a square plate with specified convective boundary condition. The geometry is 1 meter by 1 meter. The thermal conductivity along x and y direction is 120 watts per meter Kelvin. Specific heat is 800 joule per Kelvin. Mass density is 1780 kg per meter cube. The initial temperature is 300 Kelvin. The total time for analysis is 25 seconds. The time increment for analysis is 1 second. The arbitrary parameter theta for the numerical method is taken as 0.67. For creating the geometry, first go to Geometry, Key Point, Create by XYZ. Give the coordinate values for the points to be created. First point is 0, 0, 0. Then click Apply. First point is created. Next, change the coordinates to 1, 1, 0 and click Apply. Click on the label entities and switch on to point, and we can see the 2 points created. Point add done will be shown on the message box. Now go to Geometry, Surface, Rect 2P for creating the rectangular surface using the corner points. Switch on Snap to Point and select the corner points. Select first point, then drag to select the second point. Now the surface is created. Next, we can mesh this surface. Go to Mesh, FE Mesh, Quad. Then select the first surface. Give an initial size of the elements. And now set the method to paver. Now we can set the subdivisions. Right clicking or left clicking, we can adjust the subdivisions of the surface. Now the subdivisions along all the 4 edges are set to 10. Now click Apply. Now the meshed surface is ready. We can erase the surface created. Now we can see the meshed surface. We can also erase the points created. Now only elements and nodes are retained. Click on the label button to view the nodes and elements. Now set the analysis type. For that, analysis type. Select Heat Transfer Transient and click Apply. Now go to Load BC, Heat Transfer BC, Convection, Add. Click on Edge, then select the edge. Drag the left boundary nodes. Drag all the left boundary nodes in the element edge and now set the Convective film coefficient. Convective film coefficient is 1000, and now give the ambient temperature as 1500 and click apply. In the edit menu, we can see the analysis type and convection boundary condition we have given. Now go to property, material, thermal, add for setting the thermal properties. In the parameter box, select isophase and select all the element IDs. In the material data, give the conductivity values, either by loading from the library or we can directly give the values. Here the conductivity value is 120. And give the specific heat as 800. The mass density is 1780 and click OK. Now from analysis, heat transfer transient, general, add, set the initial temperature, the initial temperature is 300. Next, set the total time for analysis. Total time for analysis is 25 seconds and time increment is 1 and theta it is the default value and click apply. Now save the file to proper directory. After saving, click Run Solver to execute the file. Give confirmation as yes. Finished successfully message will be shown in the message box. Then go to Post, Contour. Select the item as temperature. Then for each time step we can see the temperature distribution. On and off the load and boundary condition to see the boundary conditions. We can zoom in and zoom out to see the temperature distribution at different time steps. Now go to Pause, History Plot. You can select the node IDs